Top 25 Java Developer Interview Questions and Answers. If you have a Java developer interview coming up, you need to prepare for more than just basic syntax questions. Employers want to know whether you understand core Java concepts, object-oriented programming, collections, exception handling, multi-threading, databases, APIs, Spring Boot, and real-world problem solving. A strong Java developer should be able to write clean code, debug issues, optimize performance, and work well in a team environment. In this video, we will cover 25 important Java developer interview questions and answers that can help you sound confident, practical, and job-ready during your interview. 1. What are the main features of Java? Java is a high-level, object-oriented programming language known for being platform-independent, secure, robust, and easy to maintain. One of Java's biggest features is write once, run anywhere, which means Java code can run on different platforms using the Java Virtual Machine. Java also supports object-oriented concepts like inheritance, encapsulation, abstraction, and polymorphism. It has automatic memory management through garbage collection, strong exception handling, multi-threading support, and a large standard library. These features make Java popular for enterprise applications, web development, Android apps, and back-end systems. 2. What is the difference between JDK, JRE, and JVM? JVM stands for Java Virtual Machine, and it is responsible for running Java bytecode. JRE stands for Java Runtime Environment, which includes the JVM and required libraries to run Java applications. JDK stands for Java Development Kit, and it includes the JRE plus development tools like the compiler, debugger, and other utilities. In simple terms, JVM runs the code, JRE provides the environment to run the code, and JDK is used to develop and compile Java programs. As a developer, we usually install the JDK. 3. What is object-oriented programming in Java? Object-oriented programming, or OOP, is a programming approach based on objects and classes. In Java, a class is like a blueprint, and an object is an actual instance of that class. OOP helps organize code in a clean, reusable, and maintainable way. The four main principles of OOP are encapsulation, inheritance, polymorphism, and abstraction. For example, in a banking application, customer, account, and transaction can be modeled as classes. OOP makes it easier to manage complex applications by separating responsibilities into different objects. 4. What is the difference between class and object? A class is a blueprint or template that defines properties and behaviors, while an object is a real instance created from that class. For example, if car is a class, then a specific car like a Toyota Corolla is an object. The class defines fields such as color, model, and speed, and methods such as start, stop, and accelerate. Objects use the structure defined by the class. In Java, we create objects using the new keyword. Classes help organize code, while objects represent actual data and behavior. 5. What is encapsulation in Java? Encapsulation means wrapping data and methods together inside a class and controlling access to that data. In Java, encapsulation is usually achieved by making variables private and providing public getter and setter methods. This protects the internal state of an object from direct outside access. For example, a bank account balance should not be changed directly from outside the class. Instead, controlled methods like deposit and withdraw should be used. Encapsulation improves security, maintainability, and flexibility because internal implementation can change without affecting outside code. 6. What is inheritance in Java? Inheritance is an object-oriented concept where one class can acquire the properties and methods of another class. The class being inherited from is called the parent or superclass, and the class that inherits is called the child or subclass. In Java, inheritance is done using the extends keyword. For example, a vehicle class may have common methods like start and stop, while car and bike can inherit those methods. Inheritance promotes code reuse, reduces duplication, and helps create a clear relationship between related classes. 7. What is polymorphism in Java? Polymorphism means one thing can take many forms. In Java, polymorphism allows the same method name or object reference to behave differently depending on the situation. There are two main types: compile-time polymorphism, and runtime polymorphism. Compile-time polymorphism is achieved through method overloading, where multiple methods have the same name but different parameters. Runtime polymorphism is achieved through method overriding, where a child class provides its own version of a parent class method. Polymorphism makes Java applications flexible, reusable, and easier to extend. 8. What is abstraction in Java? Abstraction means hiding complex implementation details and showing only the necessary features to the user. In Java, abstraction can be achieved using abstract classes and interfaces. For example, when we use a payment system, we only call a method like processPayment, but we do not need to know all the internal steps. Abstraction helps reduce complexity and makes code easier to use and maintain. It also allows developers to define common behavior while letting different classes provide their own specific implementation. 9. What is the difference between method overloading and method overriding? Method overloading happens when multiple methods in the same class have the same name but different parameters. It is resolved at compile time. Method overriding happens when a child class provides a new implementation of a method already defined in the parent class. It is resolved at runtime. For example, having add int a, int b, and add double a, double b is overloading. Redefining a parent class method in a child class is overriding. Overloading improves readability, while overriding supports runtime polymorphism. 10. What is the difference between abstract class and interface? An abstract class can have both abstract methods and concrete methods, while an interface mainly defines methods that implementing classes must provide. In modern Java, interfaces can also have default and static methods. A class can extend only one abstract class, but it can implement multiple interfaces. Abstract classes are useful when classes share common behavior and state. Interfaces are useful when we want to define a contract that unrelated classes can follow. For example, Runnable is an interface because many different classes can implement running behavior. 11. What are constructors in Java? A constructor is a special method used to initialize an object when it is created. It has the same name as the class and does not have a return type. Java provides a default constructor if no constructor is defined. Developers can also create parameterized constructors to initialize objects with specific values. For example, a user class may have a constructor that accepts name and email. Constructors help ensure objects start with valid initial data. They are commonly used in object-oriented design to make code cleaner and more reliable. 12. What is the difference between equals, and dot equals in Java? The equals operator compares references when used with objects, meaning it checks whether two variables point to the same memory location. The dot equals method compares the actual content or logical equality of objects, depending on how it is implemented. For example, two different string objects may contain the same text. Using equals may return false because they are different objects, but dot equals returns true because the text is the same. In Java interviews, this is important because incorrect comparison can create logical bugs. 13. What is the difference between string, string builder, and string buffer? String is immutable, which means once created, its value cannot be changed. Every modification creates a new string object. String builder is mutable and allows modifications without creating many new objects, making it faster for string manipulation. String buffer is also mutable, but it is synchronized, which makes it thread-safe but usually slower than string builder. If you are working in a single-threaded environment, string builder is preferred. If thread safety is required, string buffer can be used. String is best for fixed or rarely changed text. 14. What are Java collections? Java collections are a framework used to store, manage, and manipulate groups of objects. The main interfaces include list, set, queue, and map. A list allows duplicate elements and maintains order, such as ArrayList and linked list. A set does not allow duplicates, such as HashSet and TreeSet. A map stores data in key value pairs, such as HashMap and TreeMap. Collections are widely used in real projects because they provide ready-made data structures and algorithms, making development faster and more efficient. 15. What is the difference between ArrayList and linked list? ArrayList uses a dynamic array internally, while linked list uses nodes connected with references. ArrayList is usually faster for accessing elements by index because it provides direct access. However, adding or removing elements in the middle can be slower because elements may need to shift. Linked list is better for frequent insertions and deletions because it only updates links between nodes. However, accessing elements by index is slower because it must traverse the list. In most practical cases, ArrayList is commonly used unless frequent middle insertions are required. 16. What is HashMap in Java? HashMap is a collection class that stores data in key value pairs. Each key must be unique, but values can be duplicated. HashMap uses hashing to store and retrieve data efficiently. It allows one null key and multiple null values. It does not maintain insertion order. HashMap is commonly used when fast lookup is needed, such as storing user IDs with user details. However, it is not synchronized, so if multiple threads access it at the same time, concurrent HashMap may be a better choice. 17. What is exception handling in Java? Exception handling is a mechanism used to handle runtime errors without crashing the program. Java uses keywords like try, catch, finally, throw, and throws for exception handling. Code that may cause an error is placed inside a try block, and the catch block handles the exception. The finally block is usually used for cleanup tasks, like closing files or database connections. Exception handling improves application reliability and user experience because errors can be managed properly instead of stopping the whole application unexpectedly. 18. What is the difference between checked and unchecked exceptions? Checked exceptions are checked at compile time, and the developer must handle them using try-catch or declare them with throws. Examples include IO exception and SQL exception. Unchecked exceptions are checked at runtime and usually occur because of programming mistakes, such as null pointer exception, arithmetic exception, or array index out of bounds exception. Checked exceptions usually represent external problems like file or database issues. Unchecked exceptions usually indicate logic errors in code. Understanding both helps developers write safer, cleaner, and more reliable Java applications. 19. What is multithreading in Java? Multithreading allows a Java program to run multiple threads at the same time. A thread is a lightweight unit of execution. Multithreading is useful when we want to perform tasks concurrently, such as handling multiple user requests, background processing, or improving performance in certain applications. Java supports multithreading through the thread class, runnable interface, executor service, and concurrency utilities. However, multithreading must be handled carefully because it can create issues like race conditions, deadlocks, and data inconsistency if shared resources are not managed properly. 20. What is synchronization in Java? Synchronization is used to control access to shared resources when multiple threads are running at the same time. Without synchronization, two threads may modify the same data at once and create inconsistent results. In Java, synchronization can be achieved using the synchronized keyword, locks, or concurrent utilities. For example, if two threads are updating the same bank account balance, synchronization ensures that only one thread updates it at a time. However, excessive synchronization can reduce performance, so it should be used carefully and only where needed. 21. What is garbage collection in Java? Garbage collection is Java's automatic memory management process. It removes objects from memory when they are no longer being used. This helps prevent memory leaks and reduces the need for manual memory management. The JVM identifies unreachable objects and clears them from heap memory. Developers cannot force garbage collection directly, but they can suggest it using System (GC), although it is not guaranteed. Good developers still need to write memory-conscious code by avoiding unnecessary object creation and removing references when objects are no longer needed. 22. What is Spring Boot? Spring Boot is a Java framework used to build production-ready applications quickly. It simplifies Spring development by providing auto-configuration, embedded servers, starter dependencies, and minimal setup. With Spring Boot, developers can create REST APIs, microservices, and backend applications faster. For example, instead of manually configuring a Tomcat server, Spring Boot can run the application with an embedded server. It also works well with databases, security, cloud tools, and monitoring. Many companies use Spring Boot because it reduces boilerplate code and improves development speed. 23. What is REST API in Java? A REST API allows different systems to communicate over HTTP using methods like GET, POST, PUT, and DELETE. In Java, REST APIs are commonly built using Spring Boot. For example, a GET request may retrieve user details, while a POST request may create a new user. REST APIs usually exchange data in JSON format. A good Java developer should understand status codes, request validation, error handling, authentication, and clean endpoint design. REST APIs are important because most modern applications depend on communication between front-end, back-end, and external services. 24. How do you connect Java with a database? Java can connect to a database using JDBC, which stands for Java Database Connectivity. JDBC allows Java applications to send SQL queries, retrieve results, and update database records. In modern applications, developers often use frameworks like Hibernate, JPA, or Spring Data JPA to reduce boilerplate code. A typical process includes creating a connection, preparing a statement, executing the query, and handling results. It is also important to close resources properly and use prepared statements to prevent SQL injection. Database knowledge is very important for Java backend roles. 25. How do you handle performance issues in a Java application? To handle performance issues, I first identify the problem using logs, monitoring tools, profiling, and metrics. I check whether the issue is related to slow database queries, memory usage, inefficient loops, unnecessary object creation, network delays, or poor API design. After finding the root cause, I optimize carefully instead of guessing. For example, I may add indexing to database queries, use caching, improve algorithms, reduce repeated calls, or fix memory leaks. I also test changes to make sure performance improves without breaking existing functionality. Preparing for a Java developer interview is not only about memorizing definitions. You need to understand how Java works in real applications and explain your answers clearly with practical examples. Focus on core Java, object-oriented programming, collections, exceptions, multithreading, databases, REST APIs, and Spring Boot, because these areas are commonly tested in interviews. Try to connect each answer with real development situations, such as building APIs, handling errors, improving performance, or working with databases. If you can explain both the concept and its practical use, you will sound much more confident and job ready.